Good morning, friend. In today's lecture we will see concentric circular convolution method. So the number of convolutions required for a circular convolution is equals to the order of period. Okay. Now when x of n convolve with h of n, circular convolve with h of n, it is given as by using the formula summation for m is equals to 0 to n minus 1 x1 of m x2 of n minus m for the period of n. Let me take the pointer option so it will be more clear to you. Okay, now this is my one sequence and this is the second sequence. So in the second sequence, here we are going to use circular shifting property. Okay, so y of n is equals to what here? Y of n is equals to x1 of n, x1 of m circular convolved with. So this is a symbol for circular convolution, circular convolved with x2 of m. So we'll be having this formula. Now if I am considering sequence of x1 of n like this, so I am considering sequence of x1 of n like this in anti-clockwise direction, okay. So whatever we are getting the number of period for the circular convolution, that number of part we have to do for a circle. If capital N is equals to 4, so we have to make 4 part for the circle. If capital N is equal to 5, so we have to make the 5 part of a circle. So I am considering here the capital N as 4, that's why I have taken the 4 parts for a circle. Now if I am considering sequence of x1 of n as a anti-clockwise direction, then the sequence of x2 of m I have to taken as a clockwise direction, and then I am going to read as x2 of minus n for the period of n. Let me take example. I am considering sequence of x1 of n as 1 2 3 4. This is my sequence of x1 of n 1 2 3 4. So this is the sequence of I am considering x1 of n. So I have taken the sequence of x1 of n as anti-clockwise direction, considering this is my 0th position. So here I am having the 1 sample, here I am having the 2 samples, here I am having the 3 samples, and here I am having the 4 sample. Okay, now to have a x2 of m, here I require what? When I put n is equals to 0, I am going to have x2 of minus m. To have a x2 of minus m, I have to take a sequence of x2 of m in clockwise direction, because I have taken the direction of x1 of n as anti-clockwise. So direction of x2 of m, it will be the anti-clockwise. I am considering the again it is 2 3 4 1 2 3 4 and 5. This is the sequence of x2 of n. So I am writing the sequence of x2 of m in what direction? In clockwise direction. So here I am having the 2 samples, here I am having the 3 samples, here I am having the 4 samples, and here I am having the 5 samples. But if I have to read x2 of minus n, so I am going to read the sequence of x2 of m in the direction of x1 of n, because x1 of n we have taken as anti-clockwise and x2 of n we have taken as clockwise. So how to read the sequence? I am going to read the sequence as 5, then 4, then 3, then 2. This is the sequence of x2 of minus m. So I am calculating this for the value of n is equals to 0. So when I multiply these two sequences, will be getting y of 0. We will see an example, it will be more clear to you. So example I have taken as, find circular convolution of the following sequences. x1 of m I have taken as 1 2 3 4, and x2 of m I have taken as 3 1 1 3 using time domain method. So the number of convolution for the following two sequences is equals to the order of period. So here order of period is equals to 4, because here also it is 4 samples and here also it is 4 samples. If it is mentioned in the question that capital N is so and so and capital N is so and so for these sequences, so we have to take the LCM of that 2 period. So the number of convolutions we have got as 4. So that much number of samples will be having in the output sequence. So then I have to do for y of 0. So when I am going to calculate for y of 0, here it will be the x1 of m, and when I put n is equals to 0, so n is equals to 0 means what? We are getting y of 0. So n is equals to 0, we have to sketch what? We have to sketch x2 of minus m. So x2 of minus is what? You draw a sequence of x2 of m in reverse direction what you have taken for x1 of n, and read the sequence of x2 of n in the same direction of x1 of n. So we will be getting like this. See, here it is x1 of m, x2 of minus m. So I have you consider x1 of m I have considered it as x of n, and x2 of m I have considered it as h of n. So I have taken this direction as a anti-clockwise, this direction will be my clockwise, and while reading the x2 of minus n, it becomes 3 3 1 1 3. So 3 1 1 3, this is the sequence of 3 1 1 3. This is the sequence of x2 of minus m. Okay, because we have to read the sequence of x2 of minus m in this same direction. We'll be getting what? We'll be getting the x2 of minus m. Then you multiply 2 into 3 plus 1 into 3 plus 4 into 1 plus 3 into 1. We'll be getting the answer as 16. 1 into 3, this 1 into 3 plus 2 into 3 plus 3 into 1 plus 4 into 1. Similarly for y of 1, we have to rotate the sequence of this h of n in the direction of x of n by one sample. So we'll be taking this. See here y of 1. So here we'll be having 1 minus m. So minus m we are already having. So rotate this sequence, rotating by 1 unit in anti-clockwise direction of h of n, because the direction of h of n we have taken as clockwise. So we have to rotate in an anti-clockwise direction by 1 unit to have a sequence of x2 of 1 minus m. So after rotating, so initially here we'll be having the position of 3. Now it is shifted here, this 3 shifted here, 1 shifted here, and this 1 shifted here. So we'll be getting the answer for y of 1 as 20. Similarly for y of 2, again we have to rotate this sequence by unit 1 sample, because already here we have done. If we are rotating by 2 samples, we have to rotate for x2 of minus m. So here I am rotating by 1, because already this sequence is for x2 of 1 minus m. So this 1 it is shifted here, this 3 it is shifted here, this 3 it is shifted here, and this 1 it is shifted here. So we will be getting the answer for y of 2. So rotating by 1 unit, that means you are rotating for x2 of minus m. Then similarly we will be getting for y of 2 as 24. In similar way we have to go for y of 3. So rotate by unit 3 samples to the sequence of x2 of minus m, or rotate by 1 unit to the sequence of x2 of 2 minus m. So we will be getting the answer for y of 3 as 20. Now write the sequence for y of n. This contains the answer for y of 0, y of 1, y of 2, and y of 3. The position of arrow will be here, because in the original sequence before arrow there is 0 samples, and for x2 of n before arrow there will be a 0 samples. So the position of arrow will be at 16 only. Now we'll see the next example as. Now here the next example is what? Find linear convolution using circular convolution. That means what? We have to obtain a method as a circular one, but the number of samples it will be for what? It will be for linear convolutions. Now we have known for linear convolution the number of samples is equals to the samples of x of n plus samples of h of n minus 1. So 4 plus 4 minus 1, so it will be 7. So for linear convolution we will be having the 7 samples, as we can see here. But we have to use what? But we have to use circular convolution method. So here the samples are 4. So we need to add 3 zeros to make a sequence of 7 samples. So after adding these 3 zeros, the sequence will be of the 7 samples. Here also will be of the 7 samples. So this added 3 zeros, these are known as zero padding. Okay. Now we have to divide a circle into what part? We have to divide a circle into 7 part. So as you can see here, y of 0. So I have divided the circle into the 7 part, and here I have taken, this is my the zeroth position. So I have taken the sequence of x of n as anti-clockwise. Similarly, we have to taken the sequence of h of n as what? And clockwise. So here the sequence of x1 of n is nothing but the sequence of x of n, and the sequence of x2 of n is nothing but the sequence of h of n. Okay. Now here if I am going to read the sequence of h of n as in the direction of x of n, so it becomes h of minus n, so it becomes 3 0 0 0 3 1 1. This is the sequence of what? This is the sequence of h of minus n for a period of 7. Then you multiply 1 into 3, 2 into 0, 3 into 0, 4 into 0, 0 into 3, 0 into 1, 0 into 1. Will be getting the answer for y of 0. Similarly, for y of 1, you rotate by unit 1 samples, will be getting y of 1. You rotate by again unit 1 samples in the equation of y of 1, you will be getting y of 2. Similarly, we have to solve for y of 3, y of 4, y of 5 and y of 6, because the number of samples is what? Number of samples is 7. So as you can see here it is shifted. Originally here it is 3, it is shifted by unit 1 samples. Now here it is 1, so this one it is going to be shifted here, as you can see for 2. Similarly for 3 and 4, as you can see here, originally here it is 1 for the equation of y of 2, so it is shifted by 1, so 3 will be here, 1 will be here, 1 3 3 0 0 0. Now here 3 it is shifted to this position, so 3 is shifted to this position by unit 1 sample. For 4, so we will be having the answer for y of 3 as 20, y of 4 as 13. The last y of 5 and y of 6, so we will be getting this answer. Okay. So y of 5, again we have to rotate the sequence of x2 of minus m by unit 5 samples. For y of 6, x2 of minus n by unit 6 samples, or if you have the equation for y of 5, you rotate by 1 samples, will be getting for equation for y of 6. So we will be getting the answer for y of 5 as 13, y of 6 as 12, and after getting, you put the value of y of 0, y of 1, y of 2, y of 3, y of 4, y of 5, y of 6, and the position of arrow will be at 3 only. This is the position of arrow. So in this way we can solve the circular convolution using the graphical method, or it is also known as concentric circle method. Thank you very much.